Hi guys, Ben Hurley here, and today we're going to have a look at how to create an attachment for our servo motors in our Arduino kit, just like this little test one. I've just done a little round shape just to fit the servo horn in there, just to test out all of the fit and the size. But you could do whatever your imagination comes up with. You can make it into an arrow or an arm with a little hand or something like that. You can do whatever. So today I'm just going to show you how to get that servo horn and make a little slot in a print so it fits just nicely, so that we don't have any slop, so that we can manipulate something with our servo motor, whatever you want to come up with your design. So the first thing we need to do is we need to take some measurements. Now I've got another little servo horn here. I've just done it for the single arm horn, but maybe one day I might even do the same thing for the other ones. There's some other different styles of horn. There's a two-way one and even like a cross one. All right, but let's get started with this one. Now, the way I've done my measurements is I've used a pair of calipers. These are really, really nifty if you're going to be doing a lot of designs with 3D prints that you want to fit into or onto or around real things. Because you need to know what dimensions we're working with. And calipers are great for measuring things with high precision. This set of calipers can measure to an accuracy within 0.02 of a millimeter, and our printer can print to an accuracy of 0.05 of a millimeter. So I can measure more accurately than the printer can actually print. So that's pretty cool. All right, now let's go and have a look at the measurements that I've taken for this one. I'll just get a nice screen happening and bring up my notes. Okay, so the first thing is the overall length. So that's just simply the length. Ooh, it's not going to stay there. Hopefully you can see the overall length of the servo horn like that. Then I've looked at the width at its widest part. So that was a measurement that way. So basically we're measuring the diameter of that barrel part, the round part that connects to the servo motor. And then we've got the arm thickness. Okay. Oh, and you'll notice that I've got some more precise numbers here. That's what I actually measured. But then I figured, it's probably not really made to that dimension. It was probably made to, the length was probably not 19.58 mil. They probably designed it at a 20 millimeter length. And then the difference is just manufacturing inaccuracy. It's pretty close. What would that be? Half. That's probably about I think it's about a 5 or a 2.5%. Yeah, either 5 or 2.5%. I can't do maths in my head that well. Inaccuracy. That's pretty accurate. Okay, and then for the width, it came out at 6.92. So I just rounded up to 7. For the thickness, that is the thickness of this little arm bit here. You can see how the barrel is deeper and the arm is pretty thin. So I measured it that way. And that came out at 1.44, so I figured that was probably really 1.5 mil, 1.5 mil. Now, you'll notice that the arm part goes from thicker to thinner. So I wanted I needed to know the point where the arm starts and where it gets to this thin point here. So I've measured from the center, let's see if I can get a pointy thing, not from the end of the horn, from the center of the barrel over to where the arm meets the barrel. And I just sort of, did this one and lined it up by eye and just went, oh yeah, that looks like about 2 mil. So I was just going, I had my first go with round numbers and that mostly worked out pretty well. Now the arm width at the end radius, I kind of did the same thing at first. I just got my calipers and tried my best to line it up with where the straight part of the arm meets the curvy radius on the end. And that looked like about 2 millimeters, but after a couple of test runs, I found that was a little bit of the hole was a little bit too big. There was a little bit of wiggle room in there. So I did some experimenting and I found that using a measurement of 3.9 millimeters across there gave a much snugger fit. So that was a better measurement to use. We'll go with 3.9. And then the length to the small end radius, that is kind of like the overall length, but not to this end, to where the radius starts. So I found that was about 2 millimeters in. So the overall length from this end to the start of the radius is 18 millimeters. And then finally, we needed to know how thick our part needed to be. You see how this 3D printed part has a certain thickness to it? And what that is if we look at a servo that doesn't have a printed part there, that's the distance from the top of the servo horn down to that blue surface of the servo motor there. The whole print has to fit within that distance. And I actually it's got this little sticky end here. You sit it on top and we can plunge that sticky thing down until it just taps on the blue servo motor part, and that gives us our thickness, and we can read it, and that reading was 5 millimeters. Okay, so we've got our measurements, and now we just need to know what clearances we're using. Now over here it says the horn clearance I'm using is 0.15 millimeters. That's the clearance for the horn to fit inside the hole, so we're going to make that hole 0.15 millimeter bigger than the part that we measured. So I'll just remind you where we got that. Whoops. We go to our website, we go to 3D printing. Now to find all of our clearance information, we go under Flash Forge Inventor 2, because these are specific to this printer. If we had a different printer, we'd have to do a bunch of tests to see what clearances we need for the different printer. So we go down, notes for designing models. Fitting together 3D printed parts is 2 3D printed parts together. We want fitting a 3D printed part and a non-3D printed part, because our servo motor horn is a real part that we're fitting to, and our print is what we're printing. So what we're doing here is we're fitting a real part inside a 3D printed part. So we want a part inside a 3D printed part, 0.1 millimeter for a press fit. We don't really want a press fit, we want to be able to remove it, and 0.15 for a snug fit with no play. That's what we want. We want it in there tight, but be able to get it in and out easily. Okay, and then the other clearance tolerance we had was the print thickness. Okay, so the print thickness, that was the thickness of our print like this, and we measured that it was 5 millimeters down, but we want to give it a little bit of clearance so that it can move, it doesn't get bound tight, and we want that to be pretty snug. And so we want this way. So the way I see it is that the distance between here and there that we're fitting inside is a real part distance, and we're fitting our 3D printed part inside that. So we're fitting a 3D printed part inside this part. So we want this section here. We don't want a tight press fit. We don't really want a snug fit. We want a 0.1 millimeter for a slip fit, so that can move freely. So that should give us that smooth slip fit so that part can spin around nice and freely. So that's what I wrote down. Here we go. The thickness clearance is going to be a 1.1 millimeter clearance. So now that we've got all our measurements, we're ready to rock and roll. So I've already gotten my new SketchUp. Now I'm just going to start off with printing the overall dimensions. So, the dimension of it this way, what are the outsides going to be, and this way. Basically, I took the length of the horn was 20 millimeters. I'm going to put 2 extra millimeters on either side, just for a bit of thickness there. And the thickness this way, I actually made it the same as the thickness of the servo motor. That seemed like a good idea to me. So that's 12 millimeters that way. And this was 20 millimeters plus 2 lots of 2. So that's going to be 24. That's nice round numbers. So it's 12 and 24 is like a 1:2 ratio. So let's go like this. And then we'll type, we need our long dimension first. We can see down in the dimension box down here, it's giving us the long dimension first. So before we click, we just type 24, 12, enter, and that gives us our outside dimensions. Okay, now I've got a couple of rounded edges on here, so I'm going to turn each end, instead of a square box, I'm going to turn it into a half a circle. All right, so I need to mark over here with a guide where the radius comes over. So we know that our this is going to be the diameter of the rounded edge, and we only want half a circle to come down this way. Okay, it's a full circle this way, and it's a half circle this way. So that was 12, half of that was 6, so we type 6, and we'll do the same on the other end, come in 6, and we have a special tool for doing radiuses. We've got this one. I don't know why it's saying unblock plane. A 2-point arc is what we want. So we do our 2 points like this. We click on that point, and we click on that point. Now see how that, before I click, see how that's blue? It's always going to want to try and do something clever. It wants to do a half a circle, which is what I want. Okay, and I can click there. Now if I'm happy with that half a circle, I can just click again straight away, and it'll plonk in the half a circle. If I wanted a squished circle instead of a proper half a circle, I could do it this way. I could click 1, click 2, and I can drag out my arc and do a shallower arc or a bigger arc. See how it's doing part of a circle? But it just so happens I want to line up with this line right there, so I can snap there. So that's probably easier way to see why it was a 3-point arc, wasn't it? Anyway, so click on this side, click on that side, and then we can drag out and click where we want it. Or if we're happy for it to do that automatic half circle, you can let it do that. Now I'm just going to erase all these lines that I don't need, so that my part has nice rounded edges. Okay, very nice. Right, so here we go. Now I'm just going to go ahead and delete those guides. So I need to select them in a right to left direction. I think it doesn't matter if you go, yeah, it doesn't matter if you go up or down. If you go right to left, it selects wherever it touches. Okay, so now I need a couple different guides. I'm going to come up here and do a midpoint. So I want, oh, there we go. It's giving me 6 millimeters already. That's what I want. And I'm going to come over 2 millimeters there because that's where my horn starts. And I'm going to give myself an edge there. And I'm not going to come in 2 millimeters that way, and you'll probably see, you'll see why in a minute. Okay, now for our barrel part of the servo horn here, the diameter of that circle part was the same measurement as the width measurement. If we bring up our notes again, the width we measured was 7 millimeters, and we measured it that way, right? But it's the same measurement as measuring just the barrel part this way, right? So we know that our barrel diameter is 7 millimeters. That means we can come over and find the midpoint of that circle at 3.5 millimeters, and that gives us our midpoint. And, ooh, no, I have done something a little bit silly. I have started to draw my detail on the base of this servo horn. Got to watch out for that. So I actually need to delete all these lines, and I need to extrude it first and then do my details on the top. Okay, so before we go any further, that base there, that flat plane, that is where you would want to design the shape of your attachment. If you want to do something different, like a pointy arrow or a little hand or anything like that, do it when you're at this stage first, and then extrude up the whole thickness. Okay, so we're going to just go, I'm going to make it easy. I'm going to do 5 millimeters first up, and then going to bring it back 0.1 millimeters. And I'm going to check what I've done. It should be 4.9 millimeters. Okay, and then down in this length box, it gives me my answer. And you can see it's saying it's about 5 millimeters. That's not very good, is it? I don't want it to be, I don't want it to tell me it's roughly about 5 millimeters. I want it to tell me exactly what it is. That's just saying that, I mean, Google SketchUp, sorry, it's not Google SketchUp anymore. SketchUp knows that what it is exactly precisely, but it is displaying it to me in rounded up to whole millimeters. So if I want to make it more precise what it shows me, I want to use some more decimal places. So I'm going to go down here and click on the, what is this entity? Well, this is model info. And here I can change it to inches or millimeters, and I can change the precision. At the moment it's set to whole millimeters, but so I'm going to be using a 0.15 mil clearance. So I want 2 decimal places precision. So it's going to give me 2 decimal places. Okay, let's pop that back away. Measure again. Boom. 4.90 millimeters. That's exactly what I needed it to be. Right, now we're ready to go back and draw our servo horn shape onto the top face. Okay, so we need the full thickness, and then we're going to sort of think of it like we're going to cut the servo horn shape into the top. So let's get our guides back. Let's get an end guide at the end there, and we'll come in. I'm going to make sure it's following the red axis there. Come in 2 millimeters for that's the edge of the servo horn there, and then I'm going to come in 3.5 millimeters to the middle of the barrel. Put my center line back at 6 millimeters. That gives me the middle point. Now I can go ahead and draw my circle with my circle tool. Should be under the, no, it's under the rectangle tool. That's right. And then boom, 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 boom. Circle. Very good. Now I also need a guide to tell me where the arm starts about here and then where it finishes down over there. Okay, so where was my measurements? There's my measurements. So the barrel center to the arm wide end is 2 millimeters. Okay, so that's the center of the barrel. We go over 2 millimeters, and that gives me that point there where the circle meets that guide, and there, that's where the arm is going to come up to. It's going to come out like this, and it's going to come over to here. What was that measurement again? The length to the small end radius is 18 millimeters. So the overall length from back here, oops, see how that snapped to somewhere, so that wasn't going to give me a line. We'll have to be a bit careful. See how this guide here is very close to the green axis. I don't want to do it there. I might accidentally get the green axis. I'll go down here. Make sure I'm following the red axis and make that 18 millimeters. Okay, now that line there is to where the straight lines part of the arm goes to. Now I just need to remember the width of the horn over here, and I believe that was 3.9. Yep, 3.9. So what's half 3.9? I'm not going to trust myself to do maths in my head. Let's get a calculator. 3.9 divided by 2 equals 1.95. So I'm going to do a 1.95 guide there, 95, and a 1.95 down there. I could also have gone from this one and gone 3.9. That would have been the same thing. Okay, now I just need to draw some lines from here where that line meets the circle down to that intersection there, and the same on the other side. So I get a pencil, pencil. Now see how it likes to stuff around and try to give me this one? I'm going to make very sure that I've got that X where that intersection is. Draw my line there. I'm going to hit escape, so I don't want a straight line that way. I want a separate line going there to the intersection there, and escape to stop drawing. Now I'm nearly done. I just need my little radius here. Now I'm going to show you a neat trick with this arc tool. All right. Well, you saw how it automatically wants to give you a half circle. We could do a half circle, but what is smarter, because we don't have, when we were doing it here on the outside edge here, we were going to a straight line, and so that is giving you that straight line there at 90 degrees is where the angle of the circle is meeting to. So we call that tangent. That semicircle, because it's right in the middle at this point here, and it's coming up to the middle point, and that straight line is coming straight along there, that is tangent. That is going at the same, at this meeting point, that line and that circle are at the same angle right at that point. Okay, they match each other. So we could do just a semicircle, but over here it wouldn't match. See how that line is going slightly up? To do a semicircle, the line would have to be coming straight off to match the angle, to be tangent. So SketchUp is pretty clever. If we go down and click, now see how well, I haven't even clicked yet actually. Now see how the arc has gone purple and it's saying tangent at vertex. Now this arc is not a semicircle, it's not a full half of a circle. It's the part of the circle that matches, and it's going to come around and it's following the angle that this straight line is where it meets. So that circle is going to naturally fit much better to the angle of those two lines. Okay, so I'm going to click there to set that point, and I'm happy with that tangent at vertex, so I'm going to click again and it puts it in. Okay, let me just do that again. You've got to do 3 clicks for these arcs. You've got to click once, drag down, click again to tell it that's the end of the diameter, and then if you want to, you can drag out. I think I've just stuffed up my tangent. Maybe it'll give me the tangent if I drag out. No, I think it's trying to do it. Yeah, it's trying to do a half circle if I drag out. So I'll go back and I'll click and just click straight away to accept the tangent arc. So that looks really good. If we had a half circle there, it wouldn't look like it would fit quite so nicely. Alrighty, so let's get rid of all these messy guides so we can see what's going on a bit better. Right, now we're nearly sort of done. We want to change this. This is now currently the exact same dimensions as the horn, but we don't want that. We want to push it out a little bit bigger. So I'm going to get rid of this part of that circle there to make it one shape. And I'm going to give myself a bit of a better perspective. And we're going to use the offset tool. There it is. It's underneath the push-pull tool, offset tool. And we're going to click on that edge. Oop, click. And we're going to put it out. And before I click, I'm going to type 0.15. And that gives me that outside line, which gives me my clearance, my 0.15mm clearance. And now I can just go around and delete all of the inside lines that match the horn. And we can use the slightly bigger shape with our nice 0.15mm clearance. Boom. Okay. And we're ready to cut this hole down into our shape here. So we'll grab the back underneath the offset tool. We've got our extrude tool. And the first thing we're going to do is we're going to extrude down just the skinny arm thickness part, and then we'll keep going down with the circle part. So that arm thickness, let's make sure we're correct. Arm thickness was 1.5mm. So we drag it down, type 1.5, enter. Very good. Now we need to bring that part of the circle back. So I'm going to grab my swivel tool and swivel back. Now, sometimes if you're lucky, usually when you grab your circle tool or whatever, you can hover onto a radius and see how it's giving you the midpoint, and it snaps to the midpoint. But I found that with this one, it's kind of, sometimes it does it, sometimes it doesn't. Okay, see how it's not quite sure what angle to go here, and it's not really giving me my midpoint. So what I found you can do is you can do, rather than having to draw the guides out, we can hover on this one and then, see how it's following that top line and it's finding points along the left where you might like to line up to. So it's found the topmost point and the sidemost point, and that's basically found my midpoint for me. So let's go out and make sure this, looks like it's following that circle nicely. So I click there and I've got my part of the circle back. Very good. And we'll angle back. And now comes another neat trick. We don't have to worry about what distance this is to make it meet up with the edge. We can use that trick where we snap to another edge. So if we start extruding this bit, and if I come down and if I can line it up with it, see how I can line it up with that top edge? I don't want that, I want to line it up with the bottom edge. down here so that it goes exactly all the way through and doesn't keep going out the other end. See, that's too far. I want it to line perfectly with that edge, and then that completely deletes it. You can see it's not a model there anymore. It's a hole going all the way through, and that's exactly what we want. So there we have it. That's our little tester shape with a perfectly sized servo horn shape cut into it. That will go all the way through so that you can assemble that and stick the servo horn into this print first, and then together you can put that onto the servo and then screw in your little screw, and that, because that's a nice snug fit and the thickness is just right to press it up against the edge of the servo, then yeah, so because that's a nice snug fit in there, it shouldn't have any play going that way, except for it does have a little wiggle, but that's actually the teeth of the cogs inside there. That's not my print, that's the cog teeth giving that little wiggle, and it should be that 4.9 thickness, just perfect to fit between the servo horn and the edge of the servo there. So that's all stuck in place, it can't fall out, and even if you twist it around a little bit, it doesn't have terribly much play that way either. I mean, I wouldn't use that join just like that for something that was carrying some weight, like a robot arm or something like that. But for something that points, something that moves, maybe the lid on a box or something like that, that would be really, really good. Okay, so that's how you do that. It would be really cool to see if anybody does do a design of something unique to fit onto their own servo motor, and maybe show it at one of our meetup sessions. That would be really cool. So let me know how you like it, and have fun with it. See you guys.